Hello, calculus students and seekers of truth. In this video, we will find a way to express the derivative of y with respect to x, and yet using the answer in terms of t. Okay? And so I think it's best to work through this detail and then show you an example so you can see the purposes and how we use this. Okay? So, but let's just start out this way. We have a set of parametric equations, x in terms of t. And I'm just going to call this part generally f of t. Y is equal to g of t. Okay? And maybe I can relate it to an example for you, the one that we just did in the previous video. So in this example, f of t would be 2t minus 3. G of t would be t cubed. Okay? And then after you eliminate the parameter, you get an equation y in terms of x. So here is what it looks like in the general case. X is some function f in terms of t. The y coordinate is some function g in terms of t. And after we eliminate the parameter, we get y in terms of f of x. Okay, so there's a lot of letters here to keep track of. Just take a moment, maybe pause the video and try to make sense of that before you go further. And our goal is to find a way to describe dy dx, but in terms of t. So the key to unlocking this here is noticing that y is equal to g of t and y is also equal to big F of x. Okay, so this part here, using the old transitive property, we can say then that g of t is equal to big F of x. Excuse me, g of t, not g prime of t. Okay, and then now we're going to take the derivative in terms of t. Okay, so we're going to take the derivative in terms of t. I'll write that right here. Okay. So the derivative in terms of t on the left side is g prime of t. That's easy enough. On the right side, it's f prime of x times x prime of t. Now, why would that be? Because we remember here that x is actually a function, right? X is a function that's described in terms of t. Okay? And then we can rearrange. So f prime of x is equal to g prime of t divided by x prime of t. But what is x prime of t? Well, the derivative of x is just little f prime. So we can rewrite it this way. G prime of t divided by x prime of t. Sorry, f prime of little f prime of t. And that's equal to big F prime of x. So this is one way that we could describe the derivative dy dx, but in terms of t. Here is an alternate way of saying the same thing. F prime of x, so that's the derivative of y with respect to x, so that's dy dx, is equal to g prime, which is the derivative of y with respect to t, divided by f prime, which is the derivative of x with respect to t. So this is another way that you could use this information. There's another way that you could articulate this result. Okay? Both ways, it's kind of clunky to say, it's kind of clunky to do, but hopefully this helps seeing it both ways to relate the two ideas together. Okay, now you may ask, why would I want to do something like this? Well, this would be a nice example for us to work through here. Find dy dx in terms of t. Now notice here, what people typically try to do is they try to eliminate the parameter, and you do something like x equals cosine inverse of t. But cosine inverse is a rather messy function because it has these restrictions on the range and on the domain that you have to keep track of, and a lot of times the final answer doesn't really make practical sense. So in this case, it's actually the calculus turns out to be a little bit easier than the algebra. Okay? So if I want to find dy dx in terms of t, the first thing I'm going to do is I'm going to find dx dt and dy dt. So the derivative of these individual equations with respect to t. The derivative of cosine is negative sine of t. The derivative of y, dy with respect to t, dy dt, is 9t squared minus 1 over 2 square root of t. Okay. And then if I want to find dy dx, then I can just take dy dt divided by dx dt. And my final answer looks like that. Now, you might also ask, well, why would I bother doing this? Well, let's just think about what this means, right? So this is the slope of a curve. Dy dx is the slope of a curve. And t can represent a variable like time. So at a certain time, the slope of the curve looks a certain way. Let me correct this. This should not be sine of x. This should be sine of t. Okay? The correct variables here is very, very important. So there you have it, a fairly straightforward example of how do we use the derivative of y and x in parametric mode. So again, we're getting the expression is, the quantity we're looking for is dy dx, but the information that we're given is t. Okay, so we can use the variable t to find the derivative of y with respect to x. Thank you for watching. Keep working hard. Ask for help whenever you need it, and have a wonderful day.